been a very robust spacecraft. On the other hand, given that we are dealing with a spacecraft that was designed in the late 1970s and early 1980s, it's not terribly complex, and therefore, in some respects, it's not particularly adaptable to various different situations. We can't change lots of software on board the spacecraft the way you can with modern spacecraft, but on the other hand, it's very robust. There's not so much to go wrong, if you like. Simple is good in many respects for spacecraft, and it's obviously done well for Ulysses.
We'll hear more from Ulysses Mission Operations Manager Nigel Angold in 1 minute. This is Planetary Radio.
Hey, Bill Nye, the science guy here. I hope you're enjoying Planetary Radio. We put a lot of work into this show and all our other great Planetary Society projects. I've been a member since the disco era. Now I'm the Society's vice president. And you may well ask, why do we go to all this trouble? Simple. We believe in the PB&J, the passion, beauty, and joy of space exploration. You probably do too, or you wouldn't be listening. Of course, you can do more than just listen. You can become part of the action, helping us fly solar sails, discover new planets, and search for extraterrestrial intelligence and life elsewhere in the universe. Here's how to find out more.
You can learn more about the Planetary Society at our website, planetary.org/radio, or by calling 1-800-9-WORLDS. Planetary Radio listeners who aren't yet members can join and receive a Planetary Radio t-shirt. Members receive the internationally acclaimed Planetary Report magazine. That's planetary.org/radio. The Planetary Society, exploring new worlds.
Welcome back to Planetary Radio. I'm Matt Kaplan. After visiting Jupiter, the Ulysses mission has been circling our sun pole to pole, and Mission Operations Manager Nigel Angold has been watching over it. After 18 years, the spacecraft is finally running down.
In a sense, you're up against a wall. There's nothing you can do about the decay of that little piece of plutonium in the radioisotope thermal generator. But otherwise, mechanically, is this spacecraft still in pretty good shape?
The spacecraft mechanically is in excellent shape. The only problem we've had mechanically with the spacecraft is the nutation anomaly, which we got when we first deployed an axial boom, which was part of one of the instrument experiments. It was an antenna. This antenna is illuminated by the sun, and as the spacecraft rotates, it flexes. It's kind of like a bimetallic strip, if you like. And because it flexed, it transmitted motion into the spacecraft body itself, and that caused the wobble or nutation. Now, this was a problem because we have a high-gain antenna on board the spacecraft, because the transmitter on board the spacecraft is not very large, not very many watts, and therefore you need a big antenna in order to get data back from the spacecraft to Earth. And this antenna has to be it's a big parabolic dish. It has to be pointed very accurately at the Earth. And if the spacecraft wobbles, then the pointing of that antenna is compromised and you lose your data. That's really the only issue we've had. Fortunately, we found some techniques which we could use to damp the nutation by firing thrusters on board the spacecraft in an unusual way. This phenomenon occurs once in orbit as we come into perihelion, as we get closer to the Sun, and it lasts for about a year. So we've had 3 periods where we've had this problem to overcome. And we've managed to keep this wobble down to low levels, so that we've managed to have essentially a complete data set, a continuous data set from beginning of the mission until now.
I want to turn to your experience. You are an employee of ESA, the European Space Agency, and yet you have spent 18 years here in the wilds of Pasadena, or actually La Cañada, Flint Ridge, where JPL is really located. That just strikes me as such an interesting cultural experience. Can't have always been fun to be so far from home.
I'm not so sure about that. I think it's always been quite a lot of fun here. In the early days, there were a number of cultural issues to resolve, and not so much actually living here, but working here. Different ways of working between both ESA and NASA or JPL. Some very clear cultural differences, which over time we've worked through, and we now have an extremely nicely integrated team. But in the early days, there was not necessarily friction, but the way things were done from the JPL side didn't quite mesh with the way things were done from the ESA side. But from the point of view of living in Southern California, well, I wouldn't say it's too much of a hardship. I think there are worse places in the world to work and live. So I'm not going to make it out like I'm in any real hardship here.
No argument from me. I'm a native. This really was, though, I think, a pioneering mission in many ways, one of them being that it was the result of this international collaboration, which nowadays is almost par for the course. Instruments from various nations and agencies ending up on one spacecraft. But that also seems to have been sort of a pathfinding role for Ulysses. Do you get that sense?
Yes, it's true. I think we were one of the early missions to be involved with international collaboration on such a large scale. To some degree forced upon us by the fact that originally the program was 2 spacecraft and one of the spacecraft was cancelled, and one was meant to be a US spacecraft and one was meant to be a European spacecraft. That all got combined into one. So we have an odd mix of operations where the spacecraft is provided by Europe for the most part, but the radioisotope thermoelectric generator was provided by the US, Space Shuttle Discovery, which is obviously provided by the US, tracking provided by the Deep Space Network, and operations done by a European team located at JPL. It's a very strange mix, but yes, we were pioneers in that regard. And also, it's been made a lot easier, I think, by the fact that we have grown up into the age of the Internet. Certainly, I think we were one of the first missions which actually used email as opposed to faxes as its primary interface with its scientific community. We weren't originally using the Internet, but eventually, obviously, our interface with our community became through the Internet as opposed to trying to find files on a server somewhere. It has evolved. International collaboration has become a lot easier from a logistical point of view. Politically, sometimes it is, sometimes it isn't, but I'm not going to get into that too much.
Yeah, that's not one you can engineer away, unfortunately.
Not true, but I would have to say that on a working level, I've been very lucky to have been in an international environment all my working life. That's a privilege.
Are you headed home once that hydrazine freezes up and we've heard from Ulysses for the last time?
That's an interesting question. The only answer I have is another question, and that's, for me, where is home? I don't know that yet. And I will figure that out in the next few months.
Well, I hope it's not a decision you have to make for a very long time, and that Ulysses continues to do what it has done for nearly 18 years, and that is provide really groundbreaking science data back to all of us here on Earth about the Sun. Thanks so much again for joining us on Planetary Radio.
Thank you very much. It's been my pleasure.
Nigel Angold is and has been over the entire course of the Ulysses mission. Were you mission operations manager from the start? No. How did you start out?
I was the spacecraft operations manager.
Well, now he's the mission operations manager, still working for the European Space Agency, but based here at the Jet Propulsion Laboratory outside of Pasadena. We will be back with this week's edition of What's Up? And our friend Bruce Betts after a visit from Emily with this week's Q&A.
Hi, I'm Emily Lakdawalla with questions and answers. A listener asked, if a Martian sol is 40 minutes longer than an Earth day, yet they still use a 24-hour clock, how long are Martian seconds? When do they use the Mars clock and when do they use the Earth clock? Most space missions operate using Earth time based on universal time. Spacecraft computers are equipped with clocks that count up the seconds of mission elapsed time, and all spacecraft operations are conducted according to this internal clock using Earth seconds. The steady ticking of the spacecraft's own clock prevents confusion about when events are planned, particularly when most missions operate so far from Earth that there is a lag of minutes or even hours between the time that signals are sent from Earth and when they are received by a spacecraft. In addition to spacecraft time, landed Mars missions also have to keep track of local solar time. The local rising and setting of the Sun influences power availability, causes changes in lighting for images, and is related to daily weather changes, all of which are important. So mission planners keep track of local solar time using the 24-hour clock that they are familiar with. This